Hello and good morning to everyone who's watching this remotely, and thank you for joining us today. Um, so there's a famous quote attributing to Peter Drucker that culture eats strategy for breakfast, and it implies that um, you can set whatever course you want for your business, but it will be your culture that actually will determine what gets lived out in the work. And this means that most important thing that differentiates your team and your company from others is your culture. So culture and strategy go hand in hand, which means if you can define a very good strategy and ensure that the culture can support it, um, this is basically laying a very strong foundation for the success of your strategy. So my name is Nayana Shetty, and I work as a tech lead in the infrastructure delivery team at the Financial Times. And I will be talking about creating a culture of quality by embracing DevOps practices. So the FT is one of the global news and media organization, and they care a lot about the security and operability of our services. I lead a team that makes FT a safer place by creating templates to secure the Linux operating systems that the FT services run on, and also build and manage the monitoring tools needed to surface the health of our services. And we mostly work with AWS resources, Linux operating systems, and monitoring tools. FT started off many years ago as a newspaper company. And this is basically a picture taken when our paper was being printed at our print site in Bow, London. We are lucky to be able to go on tours to see this journey that a news article actually takes from being submitted by an editor to it being printed on the newspaper. The news site, I should confess, that is quite noisy, but it's fun to watch all of this happen in action. However, these days we recognize ourselves more so as a digital news media organization. And to help us with this journey, we have made quite a lot of changes in the way we work and deliver business outcomes, delivering value early, and the quality of services we build have been in the front and center of a lot of these changes. The journey that FD Tech, and in particular, the infrastructure teams have gone through over the last 4 or 5 years is pretty similar to the journey that I've had in my career. So we'll try and draw parallels where possible. So this is what I plan to cover today, and I realize there's a lot of buzzwords in this slide. I hope to explain my take on these words during my talk today. So there are 3 things I would like to cover today. So I will start off with some of the challenges we faced and the reason for moving to a mindset of whole team quality and the move from testers to QAs. We will then see how we use DevOps practices to create a culture of quality. And finally, look at some of the things that we're doing to sustain this culture. And also make some suggestions of things that you can do yourself to try and influence teams to move to a culture of whole team quality. So firstly, we will see where the FT was 4 years ago and how we moved towards a mindset of whole team quality, and make some references of where I started my career and how that's changed over time. So I started my career as a tester at NetApp Bangalore, where we had very long running projects at that time. I spent most of my time around the 6 different aspects of testing, from functional testing, performance testing, to user experience testing. And it made sense at that point with the large testing team that we had and the size of releases we were doing. Fast forwarding a few years, I moved to the UK and I started as a QA lead at the Financial Times in the infrastructure space. And here we had 5 testers for 12 team, more like the background picture here, where all of the colored uh, stick people are testers. Um, and these teams were using agile practices and delivering at a good pace. Developers, or in my case, system admins, felt like testers were slowing them down, or in some cases, because of the faster rollback options that we had, they felt like extensive testing was not necessary. And it was clear at that point that we needed a new QA strategy. So the new QA strategy was for us to move away from being the last line of defense to widen our remit and provide guidance and feedback so the teams did their own testing. And our mantra was empower, embed, and engage. So we got involved early on in the product planning phase, guiding the teams with the different aspects of quality, which meant we weren't blocking the progress of any project anymore, and the team felt more empowered. And we also paired with other members in the team while testing, making us more embedded and part of the team, and also helped us cross-skill the knowledge that we had about testing and quality. And we made sure we asked a lot of questions. And watching us ask these questions got other engineers in the team to consciously think about the way they were building services. And they started asking these questions like, what about X? Why are we doing Y? And others. And this way of asking questions is called the 5 why technique. So according to this technique, you ask why a few times to get to the root of the problem. And here's an example of why someone got late to a meeting. And after a few whys, it turns out that this was because the person was overloaded. And they realized that to make effective use of everyone's time, they will have to push back in future when they felt like they were overloaded. When we try to apply this to solving engineering problems, we end up with better designs and well thought through implementations. To help engineers come along with us on this journey, we created an engineering checklist, generic enough to be able to apply to any service that we built at the FT, but gave specific details of the different things that an engineer will have to consider while building or managing a service. And some of the themes of the thing that the checklist covered were questions like, should I build a service or buy something available off the shelf? To what sort of health checks and monitoring are needed for the service that I'm building, to the cost considerations for the service that we are building. Teams at the FT are empowered to choose the tech we want, and the proven method to bring in change in such teams is by using the principle of nudge theory, where we try and influence people without mandating anything. So instead of beating up people for not using the checklist, we ran Lego sessions where teams were building cities, and we got them to apply the engineering checklist to make the cities more robust and safer. Engineers then went back to their team and tried to apply these principles to the services they built, making our services more robust and secure. While there were a lot of teams where it was easy to get going with this QA strategy, there were challenges with a couple of teams. More so with a few infrastructure projects. These projects were long running, very manual, and very hard to slice into smaller chunks. However, we'd got to a point where assuring quality was not a job position anymore, but a role that everyone in the team had to do. So this happened around the same time when there was a reorganization inside technology. And I saw this as an opportunity to build teams that thought about quality by design and moved to a tech lead's position in one of the infrastructure teams. And when I started as a tech lead, we had one of our solution architects talk to us about the state of DevOps report from the Accelerate book. If people haven't read this book before, I would strongly recommend reading it. It's a good read. Um, this report mentions the 4 key metrics of DevOps, and it states that in high-performing teams, the lead time to deliver was less than an hour. The deployment frequency was multiple times a day. The change failures was 0 to 15%, and the mean time to recover was less than an hour. And at that point, it was a no-brainer for us, but to implement DevOps practices in our teams. So we had teams that cared about quality. Um, we'll now see some of the DevOps practices that we implemented and the benefits. So DevOps mean different things to different people. And I often use the CAMS model by Damien Edwards and John Willis to describe DevOps. And it stands for culture, automation, measurements, and sharing. And we've used CAMS model quite heavily to help us make progress in getting a culture of whole team quality. And I've seen a few good talks yesterday that touched upon the CAMS model, and I would strongly recommend going and reading going through some of those videos later if you haven't gone them, looked at them. And I'll go through how we have interpreted CAMS model and what CAMS model has meant to us in more detail. So the most important thing for me with DevOps is the culture. And culture is basically what works for you and your team, and it varies between teams, departments, and companies. Getting this right has been more important than ever in the last 6 months, when we've all been forced to work more remotely and asynchronously. I'll talk about some of the things that have worked for us so far. So with infrastructure projects, we usually hear from our users when things go wrong or break, but rarely hear the benefits of our improvements that our improvements would have brought to the business. So it can sometimes be hard for us to see the value of the work we do. And hence we encourage engineers to use the 5 why technique that I mentioned earlier to solving problem. This leads to engineers understanding the ultimate reason for building services and how that actually brings value to the FD. And this also meant we were building services with end users in mind, nudging us in the direction of better quality. And it also helped engineers understand the purpose of the team and endorse the vision of the team. And in the last few years, we have been working hard in the FD to create a diverse and inclusive work culture. And when people come from different diverse backgrounds, it is important that everyone feels safe to work in an environment. And hence, we've been putting measures in place to create a psychologically safe space for our engineers. So to make teams feel in control of their work, people in the team will have to feel safe to go wrong or to take calculated risks. And it is essential that this is not dictated from the management, but something that the team have agreed on and are comfortable with. And my team does an activity on a regular basis where we openly discuss about what psychological safety means for each one of us. And we collectively create and update a list of outlines what psychological safety means to us as a team. And in this list, we basically discuss things that we will do, like asking for feedback and inviting others to challenge our thinking, to being honest and open, and valuing each other's time, and asking questions, even if they're silly and stuff. And we also have listed the things that we will not do, like blaming individuals for the failure of a service, or avoiding difficult conversation, and others that you can see on the slide. It is good to know what we will do, but also important to be clear of the things that we will not do in the team. And another thing that we've done is defined pointers of what seniors in the team would do, and things like calling out good work that other people in the team do, or saying that I don't know things and admitting to it, and also saying out loud that we approve of others' views. And looking back at it, all of these things have helped us create a more open and a connected and a safe team. Um, Another thing that we have done in our team is allow teams to define their own quality standards, which they understand and can live by. This is an example of what my team ended up with as a result of one such exercise. And if you see the picture, quality for us does not mean just testing anymore, but also involves things like good documentation, monitoring, product management processes, and others. And the tagline we now have in the team is, for quality is being kind to our future self, which means the services are easy to maintain. We are aware that services are meant to break at some point, but now we make sure that we leave enough pointers for ourselves that fixing issues does not scare us anymore. Automation is another major pillar of DevOps. And over the last few years, we've heard quite a lot about the importance of having infrastructure as code, automated pipelines, and all of the wonderful tools that come with DevOps. Um, I think there are two common questions that teams will need to think about with automation. The first one that needs answering is, why should we automate? And a few years ago at the FT, we could only do one release every few months, and each release had a lot of changes, and we had to go through very long change management meetings and needed a lot of alignment between different teams from infrastructure, application, and operations to get a release done. And if something went wrong with the release, the rollback process was very painful. What this meant is we could only provide new features to our users once every 4 or 5 times in a year. This wasn't cool from a business perspective as well. And I think this is a story that a lot of us would have come across during your career at some point. This is the main driver for automation, so that we could have multiple releases a day. And indirectly, this means that the lead time between building a service or a feature to a user using it goes down from months to a couple of hours, or even less than an hour sometimes. Um, Humans are bound to have fatigue and oversight, and that can lead to errors. And machines, on the other hand, are very good at dealing with these kind of problems or very boring, repetitive work. And hence, we should try and automate the repetitive work. This also frees up engineers to do more innovative and interesting work. And in the past, the knowledge of how a service was built, what configurations were turned on, why a change was made, all relied heavily on people making notes or taking documentation. And very often, a lot of these were stored just in people's minds. And only a few people in the team knew how to build back a service if it all went down. Automation allows for automatic documentation of everything, from how a server was built to how an application was deployed to which test actually failed that caused us to change the configuration. And I'm sure many of you would have heard of many more similar reasons for why we should automate. The next question with automation is, what should we automate? And I think the short answer is everything if possible. In my team, we often use two key metrics to automate a task: return on investment and the pain level for doing something manually. So we often automate the repetitive work, but also think of automating very long running manual jobs that we might have to run rarely, because the pain level of running it manually is quite bad. So some of the examples of things that we've automated are our DNS configuration. So we recently moved our DNS provider to AWS Route 53. And for anyone who doesn't know what DNS is, it's a system that converts domain names from like google.com to machine readable IP addresses. And at the FT, we have around 500 domains that we own, with more than around 5,000 to 5,500 subdomains under them. And these were all records that were semi-automated to manual in the past, which meant we had no idea why we created some of these records, to who created them, or even if we still needed them. So the first thing we decided to do as part of the migration process was find a tool that could help us manage our configuration as code. And we found a tool called OctoDNS, which does this for us for DNS. And we now have all of our records in GitHub. The image here is an example of how a DNS configuration would look like. And as you can see, it is a simple YAML file with key value pairs. And with this, we now have an audit trail of every change that happens on our DNS records, with even pull requests for making changes. Once we have our configuration and infrastructure as code, the next thing to think about is the CI/CD pipeline. There are many tools available for the CI/CD itself. So it's good to pick a tool that not only automates your CI/CD process, but also allows you to configure the CI/CD pipeline itself as code. So we at the FT use Circle CI because it's easy to use and it very easily hooks up to GitHub. There are quite a lot of other tools available in the market which can do the job equally well. The image here is an example of our DNS pipeline where we initially install some dependencies, do some validations, um, run tests to see if the configurations are right, even before we can apply them on our servers. Another thing to consider is automating our tests. So we not only add unit tests and syntax checks into our pipelines, but also automate fast running high level business logic tests into our pipeline. And this is our way of instant feedback on any change that we make, and we can roll back quickly if something went wrong, sometimes even before the users notice. Um, However, one thing we have seen with automated tests over the years is we had a lot of regression tests that kept breaking every time we had to make a new release. And it took substantial amount of engineering time in fixing these problems. And hence, we decided to move away from having regression tests to having more of a monitoring checks that are running on live systems on a regular basis. And basically all the time, which gives us a quick indication when there are issues with our services. The background picture here is our operations dashboard, which gives us the state of all of the different microservices that we run at any point in time. All of the green lines against the tiles are all good services that are running healthy, and the tiles that have red lines against them are services that need fixing. And now when we release, it is easy to basically keep an eye on this dashboard to see if anything breaks. We also get Slack notifications when services break or need attention, even otherwise. The next aspect of DevOps is measurements. DevOps is a balance between culture and automation, and hence it's important to think of both of these aspects when we're measuring the success of DevOps. The question to answer to measure the automation part of DevOps is how happy are our systems and services that we've built. Here's a list of service metrics that we could consider. And these are basically outlined in the State of DevOps, the Accelerate book that I mentioned earlier. All these metrics answer questions about your service. For example, how often you deploy to production, and how is the availability of your service, and so on. It's ideal to have a dashboard of some sort for each of this service that you build, and this would give a good indication to the team of how their service are doing over time. Basically something like what the values were last week versus what the value is this week, and teams could compare their results. This would help teams retrospect on the health of their services, so that they can try and find ways to improve their services over time. At the FT, we collect a lot of this information already, and our reliability team are building a single system view. So teams can view their own, the details of the services on a single dashboard. This is an example of a single system view dashboard for a team called ES Common Tooling. And it gives us a high level view of a few different things, like the operability score, which is the percentage of systems delivered by the team which have good documentation without any critical errors or omissions. And the security score, which is the percentage of systems delivered by the team whose repositories are scanned on a regular basis. And the monitoring score, which is the percentage of systems delivered by the team which expose their operational state to monitoring. And the maintainable score, which is the percentage of systems delivered by the team which have their code and configuration stored in GitHub. And if we drill down deeper into each of the service or system, we get details of the number of security issues, monitoring alerts, open issues, and even the date when it was last released to production, and many other things. This helps the team find things they could improve on with their services in a consistent way. And in the world of microservices, this highlights things that matter most, not just to the team, but also to the business itself. And the dashboard here is an example of what the FT cares about most with our services. We have also automated our change logs and replaced all of the long cab meet or the change management meetings that we used to have before with automated change logs as part of our pipeline. And this gives us a good indication of how often we are releasing to production. And we can also see services that have issues and need fixing a lot. We also gather data about how much our service is being used to see which of our service provides most value to our users and how many errors users are seeing on the different parts of our services. The next question that, and probably the most important question when we're measuring the success of DevOps, is how happy are our people? At the FD, we've used tailored versions of the Spotify health check to get a feel of how our teams are doing over time. Like the background image here, where basically we ask questions like, do you feel like you're delivering value? Are you having fun? Do you understand the mission? Are you learning on a regular basis? And so on. And for each of these questions, we have a traffic light feedback system of red, amber, green that everyone in the team votes for. And based on the collective results from the team, we look at outliers and find ways to improve the health of the teams. However, by experience, we have found that getting measurements right is the hardest to achieve, and it is very much a work in progress for us. And if there are ways that are working for you, please feel free to ping and we can have a chat about it later. And the last part of DevOps is sharing. This is something I feel like we do champion at the FT. We are achieving this in a few different ways. Um, we do a lot of mobbing and pairing, not only for coding, but also for our infrastructure projects. This background picture here is a hangout when my team was having a pairing session or a mobbing session earlier this year when we could all be in the office. In the last 6 months, we've all had to work more flexibly and remote, and this can sometimes pose challenges to mobbing and pairing. Like the picture here suggests someone was lost and didn't have a link to where the mobbing session was happening. So now we make sure we make a conscious effort to keep everyone up to date of where the mobbing or pairing sessions are having by posting links on Slack, and also have an open Hangout link that anyone can join in for pairing or mobbing. And more recently, we've also been experimenting with asynchronous pairing, which allows us to take benefits of the flexibility around remote working, but at the same time, make sure we don't miss out on the pairing itself. Since we work on the infrastructure layer, our users are mostly internal to the FT, and we try and take advantage of this by running showcases and demos to the wider technology team more regularly. And here's an example of where a showcase presentation helped the team prioritize the next piece of work. Now that we've seen how we create a culture of quality in teams, it is more important to put measures in place to sustain this culture. I think I've mentioned a few times today that we empower our teams to choose the technology that they want to achieve business outcomes. And this means if I get called at 3 in the morning due to a database issue, it is for a database that my team would have chosen. And since it's the team that chooses the technology, each member is quite invested in it and ensures that it's at the highest quality, so that people who are on call feel a little relaxed. Um, However, with empowered teams, there is a risk of ending up with lots of different technology stacks to solve the same problem. And this is where the nudge theory comes in handy, where we have central tooling teams looking out for patterns and building standard templates that are more rounded, which is effectively a better solution than something that an individual team would come up with. And we've seen teams mostly tend to use these templates across the FT. As an example to this, my team actually built an Ansible module for securing our Amazon Linux servers, and we call it as FT base. And instead of forcing people to use this module, we have made it so easy to use that teams only have to pull down the script from a central location and run them on their servers with effectively 2 lines of code, making their servers more safer, and also reaping some of the added benefits of having a standard template because we provide features like single sign-on or basic monitoring enabled by default. We also look out for positive behaviors and try and find ways to anchor and amplify them. And hence, we have automated some of the positive behaviors. We use Slack quite heavily at the FT, and this is a snapshot of a Slack bot that reminds us on a regular basis of the sprint actions and the sprint goals that we should focus on in the team. And we also have a bot that alerts us when any documentation gets updated and is open for others to review and give feedback. One final thing to consider is to find ways to incentivize reducing tech debts and encourage learning. In the group I work in, every few months, we run a gardening day. We get everyone in the 6 to 8 infrastructure platform teams that we've got to pause all project work for a day so we can spend time fixing tech debts across the teams. We make it fun by gamifying it a little bit. So we create gardening squads for the day where the squads are formed of people who don't work in the same team. The squads score points for identifying tech debts and more points for basically fixing them. And at the end of the day, the teams with the most scores win some prizes. This way, this way of we've also got engineers to work with others they don't normally work with, learn something new, and also fix issues in our tech stacks, making us more secure and frugal. We ran one of these events in July this year, and at the end of it, we found that it was a very good exercise to reduce some of our tech debts, but also it was a good morale booster because we got people working together. More details about this can be found in the FT's technology medium blog post. So feel free to go and look at the link later, or I've got the link in the resources section later in my slide. And to summarize, it has taken us 3 to 4 years to get to where we are now. And I do believe that the journey is as important as the destination itself. And in my talk today, we saw how we consciously made engineers realize the difference between testers and QAs, and in turn between testing and quality. And we also saw how we use CAM's model to build a culture of quality. And we then saw how we use simple nudges to sustain the culture. And if there's one thing I would like all of you to take away from this talk, it is that the best way to change culture is by experimenting, continuously retrospecting, and keeping an open mind. And here are some resources I took my inspirations from. Please feel free to go through them later if you have if you're interested in any of these things. And with that, thank you. I hope you enjoyed my talk and have a good rest of the conference.
Thank you very much, Nayana, for this great talk and this great insights into your organization. I really found it fascinating, and you just said one sentence which I believe is key to your journey. You said you think DevOps is the right balance between culture and automation, and we've seen a lot of measures and lots of activities and initiatives in the sense of culture and social relations on the one hand, and we on the other hand we've seen, let's say, almost excessive automation, which is also great, and really seeing that interplay pushes all the things further. Great. We got 2 questions in the chat board, and I'd like to just read the first one. The first one is, what is the actual difference between a regression test and a monitoring check?
I think that's a very good question. So we've had this same questions come from our engineers as well. So in the past, we've got these regression tests, which are very long running. So your heavy business logic tests, which take like 5 minutes to 10 minutes sometimes to actually figure out what's happening with your service. These are all regression tests, which often are bound to break because of even very small changes that we make, where monitoring checks are very lightweight, and they look at the internals of your systems, and also you add checks that give you the business logic validation with very lightweight. So each check wouldn't take more than like 5-10 seconds.
Okay, thank you. I hope this answers the questions. And here's another one. Let me read it. What parameters you monitor in operational dashboard of all your services? What parameters do you monitor?
Yes, that's again a very excellent question. I think a lot of different teams have been using different methods over time. And what we've settled down with these days is we use the use method and the red method for our monitoring. And for anyone who doesn't know what use method, red method means. So use is utilization, saturation, and errors for your servers. And the red method, which is rate, error, and duration of your each individual request for your API request. So these are the 2 methods that we've used, and we've consistently used it for all our services. So it's easy for us to flip between our microservices to see what if something is broken. And it's quite lightweight. So we know that it's these 8 or 9 checks that we've got for each one of our applications that we will have to look into. And from an operational perspective, for someone who's looking at that dashboard that I showed earlier, where there was hundreds of services, it's going to be very hard for them to figure out if they had tailored checks for each one of our applications. So we keep it quite consistent with all our applications. I hope that's answered the question.
Cool. So then let me say again, thank you very much. And if you from the audience would like to clap virtually, then please do so in the chat. I really believe it's a great talk. Thank you so much, Nayana, for opening up together with me this online conference. And I'm really happy if we can meet in person at one of the future, hopefully physical conferences, yeah, after we've solved, or the humanity have solved this pandemic problem, which is unfortunately still there. So thank you very much. And please do not forget to rate the keynote you've been watching here. And as I said in the morning, please give feedback as much as possible. And having said that, I'd like to say goodbye to you, Nayana. Maybe you continue to follow some of the sessions over the day in case you got time. I'm going to do this as well. And please enjoy the following sessions over the day. And as I said, they're going to be moderated by my colleagues, Dominic and Jan. And around lunchtime, there's a break. And then in the afternoon, there are lots of more sessions. And enjoy the day. And we meet again for tomorrow's morning's keynote right here in the morning. Have a good day. Bye-bye.
Thank you. Bye.